Good morning, everyone. It is Thursday, day 4 of week 1 of Web Fundamentals. We're going to dive into our morning algorithms. So I'm going to go ahead and do that now. Here we are. If you go to the algorithm section on the platform, week 1, day 4, we have code flow functions, var x equals 5. And we have a function. So how does a function call work? We have the word, the function name. First, we have the keyword function. Function. Do something. Then we have the parentheses, opening bracket, closing bracket. We've been calling this the do something section. So we do something here. And then once we call the function, well, once we define the function, what do we have to do afterward? If we want it to run.
Return.
What was that?
Return.
We have what does return do? Well, that's not the answer actually. What I'm actually asking is how do we make this function run? We defined it.
You have to put outside the parameters, right? Do something and then parentheses, whatever you want it to run.
Yes, this will cause the function to run. This here. It won't run unless you call the function. Okay. So in this example, we have this function set x. Here, we take in a new value, right? So we've gone over this function set x. In this area, what is this area called? What do we take in here?
Parameter, right?
Parameter, right? So what's a type of parameter? What does it do?
Sets a value or?
Yeah, it's a placeholder for a value. So if I say, let's just call whatever gets entered into here the value. And if I call this function here, and I give it the value of 5, if I say console log value, it'll give me 5, right?
Yeah.
If I say set x and I say 6, then what's the second value it would give?
6.
6, right? Easy enough. Okay. So what if I say function set x and I say value here. And then here, I say return value. Okay. Now, how do I call this function so that I get a console log of the value?
Console.log and then set x
There it is.
value.
So we say console.log, and inside the parentheses of these here, of this console log, inside here we say set x. Set x, and then we'll call it with, let's say 5. this 5 will pass into this value. This value will give it here in the return. So when we console log this function with the 5, then we are console logging the function call. And what we say is when we have a return, it gives value to the function. So when we console log this function, we're console logging 5. It gets set in this console log, it gives given to this value, it gets given to the return, it gives it back to the function. So then when we console log the function, we're getting back the 5 that we already entered into it. And in the console log, it's in the console itself, that separate area, we'll get a print of 5. We all know this, right? Okay. Does anyone have any questions about this, how this works? I think we've gone over this plenty. So we have a return. Here we have a console log. We have a variable, and the variable is also equal to a function call. So when we console log the variable, it's as if we're console logging the function call itself, right? Does that make sense? If we're console logging a variable and a variable is equal to the function call, it's the same thing that we just did where we're console logging here the function call itself. So we know how to do return. So we're going to do these two algorithms. Just console log, just T-diagram this. Very simple. Then we have this return one. Console log everything that would happen here. Show me in a T-diagram how it would work. Okay, be ready to present. If you get to the third one here, be ready to present any of the first two as well for your group. Now we have a third as well called a palindrome. We have to, a palindrome is a word that is spelled the same way read forwards or backwards. So race car, if you spell it forward, R-A-C-E-C-A-R. If you spell it backwards, R-A-C-E-C-A-R. Same with taco cat. Taco cat, you spell it the same way forward and backward. So let's say we had a function that anytime we passed in a word, it would check to see if this was a palindrome. So here we have this function. Function is pal, takes in an array. So if we skip all the way down here, we say var result1 equals is pal, takes in 1 1 2 2 1. We can look at this and intuitively know it's not a palindrome by just looking at the middle and seeing, is the left right the same? If it's not, then it's not a palindrome. But we need to make the machine to be able to see that. So whatever method that we use to look at this array and determine if it's a palindrome is the way that we would tell it to check for any array length. Because what if we had a number that was thousands long? We couldn't just look at it intuitively and know, is this a palindrome? So we have to give a certain rule. All right, in this instance, we can look for the middle one here and determine if its integer to the left matches the right. Or we can start from the edges. We can read from the edges and say, is the one on the outermost edge the same as the one on the outermost edge on the other side? Yes. So let's see what this one does. For var left equals 0, okay, so we're starting at position 0. That's this leftmost here. We say left, while left is less than array length divided by 2. So that's halfway through the array. while left is less than halfway through the array, increase left. And then we say the one on the right, var right equals array.length minus 1 minus left. See, right now you may be wondering, why is it minus left? I thought array.length minus 1, that would give us this position here. Well, it's true, but as we increase left, as we go through this for loop, as we increase left, the higher left gets, the more we can use that number to subtract and go from the right. So what if we wanted to check the second values? And we say r.length minus 1. Okay, we're still here, minus left. If we've increased left to 1, then we're also going from right to left here as well. If r at left is not equal to r at right, then return not a palindrome. If at any point this qualifies, then we're going to return with this string. Otherwise, we're going to return palindrome.
I'm stuck at array length divided by 2.
So array length divided by 2, the reason we want to stop there is because we're not going to check the whole entire array. Remember,
But what does that mean, array length divided by 2?
it means half of the array. So if our array length is 10, divided by 2 would be 5, right?
But this one's 5 divided by 2.
Array length divided by 2, then that would be
2.5.
2.5. All right. So what is there any drawbacks to having a decimal value here? Think about that. Test it with this here, r.length divided by 2. If there is a drawback, what can we use to fix this? We have math.floor, ceiling, round.
Round ceiling.
But yeah, there's different ways around it. But is this even going to be any trouble? If in this case we have 5 and it checks past 2.5, is that going to make any difference in whether there's an accuracy or not?
No, because the third letter is going to be the same no matter what.
Yeah, it's just when you pass that point, when you pass 2.5, it was only checking to see if it's less than 2.5. If you pass 2.5, then you've gone too far for left. That would make it also go too far for right as well. Okay, so T-diagram this one. Explain to me how this works, how we can check a palindrome for any array. Okay, so this will be our third, and we have to introduce something that's going to be an important method for how we split up and do algos. We have this concept called the driver, the navigator, and the Kaya, what's the third one?
The presenter.
The presenter. Okay, so if you are the most confident in explaining how to get to the answer, you should be the navigator. You should be telling other people what to write in code. So someone else that has less confidence in writing the code, at least at this stage when we were figuring something out, you should be the driver, which means that you should be writing the code, okay, for the navigator. That way the navigator has a chance to explain how the code should be written. And you are gaining skill in giving instructions with clear meaning. Okay, the driver then has to understand and interpret those instructions and write that on a screen. So anytime I jump into a room, there should be a screen shared. That should be the driver's screen. Okay, we don't want the navigator and driver and presenter to be all in one. Okay, so if you're not the navigator or the driver, you should be able to understand everything that's going on and to be able to present in your group as well. So you want to be able to present even if you had no part in making the solution. Okay, everyone should fully understand how to make this work And everyone should have the presentation skills that we would help you gain in this course. Okay, so we have 3 algorithms we're going to T-diagram this morning. You guys should be able to handle the first 2 pretty easy, and the last one as well. Okay, so we'll have about 40 minutes to do this. Actually, probably less, because that would put us at the very end of the hour. So let's say 30 minutes, and then that gives us 10 minutes each, and then we'll present at the very end. Okay, does anyone have any questions? Okay, let's go ahead and get started. Welcome back, everyone. Let's give our solutions to the answers. Who would like to present first for problem 1?
I don't mind.
Okay,
So my thing is a mess, so don't worry about it. But for the first one, we start with variable x is equal to 5. It sets it. It doesn't call anything yet. It just console logs x. So the first console log is 5. Then now it's running the function at 15. So x's new value is 15. And then it console logs x at the new value, which is 15. So it's just 5 comma 15.
right.
All right,
That's it.
that's it.
Cool. All right. For question 2, let's have another group.
Okay, I'll go.
Thank you, Joan.
Sorry, Mike. I guess no one was volunteering. Okay, so number 2, the function is as written on the left. So the first and the T diagram is on the right. So there is some color coding here, so you can see the function in green and the variables in yellow and the results in what color is that? Pink. Anyway, so we assigned the first value of x as 5, and what the function is called on line 7 there. So it says add to x is assigned a value of -10. And then what it does, it adds on line 3, 10 to the value, add 10 is added, -10 is added to x, which is assigned 5. So that will be 5 minus 10, which gives us a -5. So it says, so as soon as you return something, I guess you get out of the function. So as soon as we return on line 3, we jump to, wait, hold on, did I say that right?
Well, is there any way we can make the text a little bit bigger? It's hard for me to follow the explanation.
Okay, sorry, I skipped something else. So we wrote the first console log value as 5 because line 1 actually, so the function is not actually called until line 7. So we go through line 6 first, where we console log the value of x, which is 5. So that's
Right.
the value. And then line 7, like I explained, goes through the function. So we have 5 minus 10, which returns a value of -5. So then line 8, which is the next line, logs the result, which is -5.
Okay.
And then right after that, the next line to be ran will be line 9, which logs the value of x, which didn't exactly change. So that's still 5. So console log will give us 5, -5, 5.
Nice. That's it. Okay. 5, -5, 5. Do we all understand how we got this? We have 2 console logs. They should all return the same value. The only time the value changes is when you give a variable called result. You make it equal to the function call that you give it 10. And then you return x plus amount. And you console log hello there. So does at any point our console log say hello there?
No, because as soon as you return, you get out of the function.
Right, because the console log is below the return, console log is never going to trigger. So anything that happens after the return is never going to trigger. Okay, good job, Joan. All right, for the next question, question 3.
I'll go. Zach, you want to bring up your screen?
Yeah. And Tillman, I'll give you control of it.
Yeah.
Also,
Trying to bring up. Do you have the where do I find the actual
here, let me
question?
here, give me one. I can share my whole screen. Give me one sec. Okay.
Okay, here we go. Okay, so for this one, first and foremost, we have to create 2 T diagrams to log each of the variables, result 1 and result 2. So for result 1, we are logging in this array, and then we're
Which array? The one that says 1 1 2 2 1?
Yeah, 1 1 2 2 1. Putting that in first, and then going through the for loop. So left is 0 and left is less than the array dot length divided by 2, which is halfway through, and right equals the array length minus 1 minus left, which is the full array length is 5 minus 1 minus left is 0. So it is 4. So it's starting here 0 1 2 3 4. So it's checking 0 and 4, which both equal 1. And so it's saying if left and right are not equal to each other, which they are. So we go back up. Left is incremented by 1. And then right is also incremented by 1 because right, the left value is 1. So 5 minus 1 minus 1 is 3, and 1 and 3 are not equal. So this becomes true. It's returning not a palindrome. And then we exit, and then we log in the second T diagram, the second value of this array, 3 2 1 1 2 3, and go through the same iteration back up top here. Left is 0. Right is 6 minus 1 minus 0. So that is 5. Starting here, 3 and 3. They both equal each other. So this is not true. Back up top to the increment left by 1. Left is now 1. And right is decremented by 1. So that is 4. So 1 and 4, they equal each other. Back up top, incremented by 1. Left is now 2. And then right is now 3 because we incremented that. And they equal each other. Back up top. And this condition is no longer met. And so we return palindrome and result console log result 1, console log result 2, not a palindrome.
Okay. Okay. Well, can you move your that to the bottom?
Where?
Just anywhere off the screen.
This?
Yeah. can minimize it. Okay, I'm glad you guys are doing well now. You guys understand pretty much everything we've thrown at you. The only thing I want you guys to do better now is presenting a T diagram as an answer. So when we work in groups and we log our T diagram as proof of our work, what we want to be able to do with that T diagram is when we present our solution, present our answers, we want to build a T diagram from scratch and be able to do it from scratch based on those notes that we have. So share notes among yourselves and be able to do it like this. Anytime you encounter it, write it here from scratch. So for the first thing we see here, we see the first one is going to be result 1. And then that's equal to is pal. With this here, it's going to be a little bit tedious, but the more practice you get presenting in front of people from scratch, the less awkward it's going to be in front of your interviewer. So get the awkward mistakes out of the way here while you have a group of people to practice in front of. You'll realize how valuable this is once you no longer have it. So result 1 is pal. Okay, so we go in here, we say var left is 0. Okay, and then we also say while left is less than array length dot 2, what is r dot length divided by 2? It is, should have moved it over to the left a little bit there, but okay, r dot length divided by 2, and this point is 2.5. So then we say var right. You guys get the idea. All I'm doing is doing this from scratch in my presentation, because when we have a fully charted T diagram that we're presenting and we're reading it, we can read it in our head based on where we know we've been on that T diagram that we're showing on the screen. We just now need to be able to explain it. So without a doubt, you can, recite the whole entire process step by step and explain why at this point when left is 1 and right is 3, how it would trigger that if statement. If r at left is not equal to r at right, then we return and show that console log of the return. So like I said, you guys are doing really good and you're understanding. Only thing I ask now is when we're presenting, even though we've T diagrammed it, we have a nice chart, either through Zoom skills or a fresh new Google Docs section area where we're T diagramming again from start, so that we have that skill of doing it from start in front of people. Okay, that's it. And other than that, you guys give yourselves a pat on the back. You guys are doing well. We're going to go ahead and take our 10-minute break here and get started on position. Okay. Does anyone have any questions about this morning's algo? Does every group understand how the is palindrome function works? Yeah, no questions at all? Okay.